All right, in this Excel activity, there are two main objectives. I want to take this data, in this case it's the weight of 70 individual pennies. So I want to take this unsorted data and first create a frequency distribution table, and then once we have the frequency distribution table, we'll graph it as a histogram. And so just to remind you, we made the distinction in the very beginning of the course between quantitative versus qualitative data. So we have two different graphs, very similar, bar graph and histogram. They both consist of vertical bars. The height of each bar is the number of data values. So with a regular frequency distribution table, we could use a bar graph if we're dealing with categorical data or qualitative data. Once we start grouping the data into classes, then we use a histogram. They're both vertical. Technically, they're both types of bar graphs, but what we call a bar graph is counting individual values, counting repeated values. In a group distribution, we're counting how many values occur within a certain range. So for that to happen, of course, the data has to be numerically valued. In a bar graph, the bars are separated by some space. In a histogram, the bars are adjacent. Okay, so back to the Excel activity. And again, this came up in an earlier Excel sheet. I'm going to show you how to use Excel to count two different ways. So I copied two frequency distributions. The one on the left, I'll be using the more complicated count-ifs function. I'll go through that with you again. You might want to just focus on the one on the right, just the count function. In this case, since we have 6 individual classes, you'll have to do it in 6 different steps. That's the drawback with the count function. If you're using the count-ifs function, you could complete the whole counting process, each of the 6 individual frequencies, all in one step. So, and actually also, if we're using the count function, we can't have our data in a 2-dimensional array like this. We have to rearrange our data into a single column. So if I'm using the count-ifs function, what I'm basically doing is I want Excel to sort through or to scan this whole block of data. And for example, this first block where I have my cursor, I want Excel to tell me how many of those numbers are in the range 2.4 to 2.49. So the formula for this is, so basically I'm telling Excel to count if a number is in that range. That's why it's called the count-if function. So I'll say equal, count if, and actually there's 2 requirements, so I need plural. So ifs, count ifs, because we have basically 2 requirements. It's above the lower bound and also below the upper bound. So when I say between 2.4, 2.49, it's bigger than or equal to this, but also smaller than or equal to this. So we'll have to enter those 2 things separately. So I'm going to take my data. So I'm basically counting if my data. Now, remember, we're going to be using the same data for each of the 6 frequencies. So if our data, and now I want to say, is greater than or equal to the lower bound. So for that parameter, in Excel, the syntax we need is quotation marks. So greater than, equal to, close quote. So I'm basically taking this data, A3 to G12, and saying count any number if it is greater than or equal to, and I'll link it to the lower bound with an ampersand. So that and lower bound, which is J9. Now there's a second part of this function, so comma. Now I want to take the data and count if, so comma, less than or equal to the upper bound. So in quotation marks, I will say less than, equal to, close quotation marks, comma, and I'll link that to with an ampersand. I think that's called an ampersand, whatever that symbol is above the 7 key. And the the upper bound, which is in J10. Okay, so let's see if that works. No. What's wrong with the problem here? So equal to, oh, sorry, comma shouldn't be there. Okay, so what this is saying right now is count any number in this data that is greater than or equal to the lower bound, and also from this data less than or equal to the upper bound. The problem is, if I want to copy this formula down, Excel is going to increase the index on, in this case, if you look up here at the formula bar, the A3, if I drag the formula down, will become A4 and then A5, but I want it to stay A3. So remember, we need $signs on the PC. Shortcut is function F4. I don't know what the keyboard shortcut is on Mac. Unfortunately, you can look it up, or you can just manually put in $signs. So, function F4. So I'm going to freeze the A3 to G12, and again I'll freeze the A3 to G12. So if you look up here on the function bar, count ifs, 2 criteria. 1, our data is greater than or equal to the lower bound. And, I actually have a problem with my formula. That should not say J10. Sorry, that should say K9. So our data greater than or equal to the lower bound, which is here in red, and then data less than or equal to upper bound, which is in purple over here. And now, the benefit of this, especially if the distribution or the criteria you're counting, or the table you're using, if there's a lot of classes, you type this in once, and you could drag down the formula, and Excel will update the formula. So now, if you look at the function bar, we have J10 and K10 for the next class, J11, K11, so on and so on. Again, I'm showing you this just so you're aware that every single function in Excel is not as basic as just equal, average, parentheses, data. The functions are not just one step. So this is more to just give you a feel for where you might go if you continue learning Excel. What I recommend is maybe doing the counting this way, using the count function. So basically, if you just say equal count, highlight some data, Excel will tell you how many pieces of data you have. So the only issue here is we need the data in one column. So I'm going to copy this data, and unfortunately I'm going to have to copy it column by column. So that's 1, 2, 3, and in the next Excel file that I have Excel intro number 4 with notes, I've done this cut and paste, copy the data into one column for you. The reason I specifically gave the data in this like 2-dimensional block is to just let you know that sometimes data is annoying to work with. Like when you pull raw data off the internet, sometimes it's not in the form you need it. So this first step with any sort of data analysis is to gather your data and arrange it or organize it in a form that you could work with. 2 more to go. Now while I'm doing this, just to go back to the point of what we're doing here. Like, why are we making this frequency distribution? Our goal, well, two goals. One, to abbreviate the data, so we have we'll be working with 6 numbers instead of the 70. But also, a frequency distribution allows us to identify patterns in our data that we may not be able to see, or most likely won't be able to see if we're just looking at raw data. So, for example, if you look at this, it's very difficult to notice any sort of discernible pattern in this data. But as soon as I pop it into a frequency distribution, what I see here is I see a very clear pattern. I see there's a lot of data grouped here, then there's a gap, and then there's a lot of data grouped here. And just that simple situation, it's almost impossible to see if you're just looking at this random array of numbers. Okay, so let me go back to this. So what I want to do here is use the count function to count how many data values are in this range. Now, notice the difference. If I'm using the countifs function, I need to reference the number, which is the lower bound, and I need to reference the number, which is the upper bound. So I had to keep those two in separate cells. If I'm using just the count, just the regular count function, I just could write the 2.40-2.49. Excel is reading that as text. And those are actually going to be the labels on our histogram. So, how many numbers in column S are from 2.4 to 2.49? Well, first thing we should do is put them in order. So I could highlight the whole column, and over here up at the top right, sort and filter. We'll rearrange them smallest to largest. And in one click, done. Excel's done the sorting for you. So here I could say equals count, and I'm manually just going to highlight all of the numbers from 2.4 to 2.49. And it's as simple as that, 18. I'll actually change this to, I'll format the cell so there's no decimal points. Number, decimal places down to 0. So 18. And of course we get the same result whether we're using the countifs function or the count function. But the drawback to this, it's a simpler function. It's just equal, count, data, done. The drawback is you have to do it manually for each range of values. So now for 2.5 to 2.59, I'll say equal count, and then I'll highlight the data. I'll highlight the cells containing data or numbers from 2.5, and I'll stop when I get to 2.59. And there was 2.59. So I basically have those numbers. I'm manually applying the count function to those particular numbers. And so we get the same 19. There's nothing from 2.6 to 2.69. I'll just manually put in 0 there. Oop, that's not a 0. And then again, continuing on, next class is 2.7, 2.79. So I will manually equal, apply the count function, and again, I'll start with the cell containing the first number, and I'll highlight up until the cell containing the last number. Obviously, you could see that there's only 2 numbers, so you don't need an Excel formula to count 2 numbers, but just to, here the point is not should we be using this function. The point is just showing you how this function works. And next one, 2.8 to 2.89. I will start with the cell containing 2.8, highlight down to the last number in this range, which is 2.89. And again, I'm manually applying the count function to the range of data that corresponds to this particular class in the frequency distribution. And one more to go. Equal count. So now you see I'm using a much simpler Excel formula, but there's repetition. I'm having to do this 6 individual times. If your distribution has 20 classes, let's say this is not something you might want to do. No, 1 second. Sorry, at the airport there was an announcement there for a second. And here we go, done. And you can see the frequency distribution table on the left and the right are giving us the same values. So now what I want to do is take this frequency distribution and graph it. And the visualization we use for a grouped frequency distribution table is the histogram. So with Excel, inserting graphs is very easy, 1 click. So I'll go to Insert, and you just, up here, just pick the one that looks like the graphic you're trying to make. So right here, this looks sort of like a histogram bar chart, okay? So what I'm going to have to do is highlight the data I want to graph, and then click on Insert Column or Bar Graph. I think that actually if we can maybe include the labels as well. Let's see how that works. Okay, so we get a very basic, what's that? Yeah, we get a very basic graph. It's not actually a frequency. It's not actually a histogram because there are gaps between the bars. So we could fix that on this version of Excel. And different versions of Excel, Mac versus PC, or Excel 2010 versus 2016, there might be slight differences. I'm using Excel 2016. I'll click on one of the bars and format. Format data series, and whether this is how you get to this particular option, gap width. If you're using a Mac, it might be slightly different, but you can change the gap width. In this case, I will change it to 0. So it eliminates the gap in between bars, so now the bar graph becomes a histogram. We have labels on the horizontal axis and frequencies on the vertical axis. One thing I like to do is just so the individual bars don't sort of blur into each other, they're the same color. Very quickly, but also very effective, I like to vary colors by point. It just makes it a little easier to quickly understand what's going on in the graph. You can add titles to the horizontal and vertical axes. Here, if I click this plus sign, I can add axis titles, let's say. Very easy to do. And I could call this, let's say, classes. Maybe make it a little bigger. So I'll let you play around with the formatting, the graph. The histogram I have on my solution file is a little bit more cleaned up, but that's basically that's as easy as it is to make a histogram on Excel. Once you have a frequency distribution, copy, insert, bar graph. And then once you have the bar graph, you know, a little bit of formatting is all you need. Get rid of the gaps between the bars, maybe change the colors. You could play around with the formatting to see what you could do. Rule of thumb, the simpler the better. So don't go overboard with the formatting. You don't need to make shadows and three-dimensional and, polka dots and stripes, things like this. Just if the changes you're making are not going to make it easier for someone to understand your graph, then it's probably not worth doing it. And that is that. Actually, so now what what have we learned? Well, what have we, like what sort of pattern have we uncovered? It looks like there are two types of pennies. There are a lot of pennies out there that weigh between 2.4 and 2.6 grams. And then there are a lot of pennies that weigh between 2.8 and 2.99 or 2.8 and 3 grams. What actually happened is at some point, during some year, the government changed I believe it was the zinc to copper ratio in the penny. So after a certain year, pennies started weighing less. So I have this on my solution file if you want to read it. I think I got it off of maybe Wikipedia or something. From a certain year below, pennies were heavier, maybe they had more copper, and then newer pennies, lighter, they had less copper, something like that. Okay, hope this helps.